Hello everyone. This is our second lecture of Laplace and inverse Laplace transform. In my first lecture, we have learned the basic 9 formulas of Laplace and inverse Laplace transform. And today's topic is first shifting property and second shifting property. Obviously, for both Laplace and Laplace inverse transform. Okay. So before starting, first shifting property and second shifting property, let's understand when and how we can use this fast shifting property. Suppose we have a function e to the power at f of t. Okay, this is our given function. Now we have to apply Laplace on this function. That means Laplace of e to the power at f of t. So when you can see that the given function f of t, this is multiplied by an exponential, in that case you can use fast shifting property. Okay, if the given function f of t is multiplied by any exponential, in that case you can use fast shifting property. So Laplace of e to the power at f of t, that will be equals to just simple f of s minus a. That means you have to replace s, by s minus a. And what is f of s? F of s is nothing but this is Laplace of f of t. Clear? So let's write the property, first shifting property. So if Laplace of f of t, this is equals to f of s, then Laplace of e to the power at f of t, that is equals to just f of s minus a. Clear? So first step is you have to find out what is f of t. Okay, then from f of t you can find out f of s. Okay, then after getting f of s, you can use the formula of fast shifting property. So from here just you have to replace s by s minus a. This is the process. Okay, first you have to identify which one is f of t, then from f of t just apply Laplace and you will get f of s, then replace s by s minus a and you will get the result. And what is a? A is nothing but the power e to the power at, this number a, this is the number a. Okay, let's try an example. Okay, before that let me tell you what is the uh, fast shifting property for inverse Laplace transform. Just opposite. Here the result is Laplace of e to the power at f of t. This is equals to f of s. Now if I apply Laplace inverse, so Laplace inverse Laplace e to the power at f of t, this is equals to Laplace inverse f of s minus a. Yes or no? So this Laplace inverse and Laplace, both operator cancelled. So you are getting Laplace inverse f of s minus a. This is equals to e to the power at f of t. So this is your fast shifting property for inverse Laplace transform. Okay, and this one fast shifting property for Laplace transform. Clear? This one is fast shifting property for Laplace transform and this is for inverse Laplace transform. Okay, remember if the given function f of t is multiplied by e to the power at, then you can apply fast shifting property. Similarly, if in any function if f of s, if you can see that s is replaced by s minus a, in that case you can use fast shifting property for inverse Laplace transform. Okay, let's understand using an example. Question: find Laplace transform of e to the power minus 2t into sine 3t. Okay, you have to find out the Laplace transform of this function. obviously you can see the exponential, that means e to the power minus 2t. This is multiplied by the function sine 3t. Yes or no? That means here f of t is equals to sine 3t. Clear? F of t equals to sine 3t. Now just simple find out Laplace of sine 3t. And you know the formula, a by s square plus s square. That means this will be 3 by s square plus 9. Okay, so obviously this is your f of s. Now you have to find out Laplace of e to the power minus 2t sine of 3t. So here a is equals to minus 2 and formula is f of s minus a. So a is equals to minus 2, that means you have to write f of s plus 2. So just in place of s you have to write s plus 2. Okay, so the answer is 3 by s plus 2 whole square plus 9. Clear? Now simplify this, so you are getting 3 by s square plus, so this will be 4s plus 13. Okay, very simple, fast shifting property. Let's solve another problem. Question is, here Laplace of f of t is given. Okay, so if Laplace of f of t, this is equals to s by s square plus s plus 4. Okay, find Laplace of e to the power minus 3t f of t. Clear? So you need not to calculate what is f of t, because Laplace of f of t already given. Actually we need f of s, and f of s is already given. Just you have to replace s by s minus a. And in this problem, what is the value of a? You can see a is equals to minus 3. That means f of s, that will be replaced by f of s minus a, that is equals to f of s plus 3. Clear? So if you replace it, so Laplace of e to the power minus 3t f of t, that is equals to s plus 3 divided by s plus 3 whole square plus s plus 3 plus 4. Okay, just simplify this, s plus 3 divided by, so this will be s square, and this is 6x plus s, that means 7s, plus this is 9 plus 3 plus 4, that means 16. Okay, so s plus 3 divided by s square plus 7s plus 16, this is the answer. Okay, let's try a problem of inverse Laplace transform. So next question, find Laplace inverse of 6s minus 4 divided by s square minus 4s plus 20. Okay, the formula is, you have to apply Laplace inverse f of s minus a, this is equals to e to the power at f of t. This is the formula, but in this problem you are not getting this form, f of s minus a form. That means you have to convert this f of s in this form, s minus a. Okay, actually you can see here the term is s square minus 4s. So you can use this concept that s square minus 4s, you can write s square, sorry, you can write s minus 2 in this form, s minus 2 whole square. Yes or no? So let's use this concept. So this is equals to Laplace inverse First, I am writing the denominator. So you can write s minus 2 whole square. S minus 2 whole square, that means s square minus 4s plus 4. But here the term is plus 20. That means you have to write plus 16. Yes or no? S square minus 4s plus 4 plus 16. Clear? So in place of s, you are getting s minus 2. Similarly, our target is you have to write s minus 2 in numerator. Okay. So if I take 6 common. So 6 into s minus 2. Okay. 6 into s minus 2. That means this is minus 12. But in question, this is given minus 4. So we have to add plus 8. Check it. So from the numerator, you are getting 6s minus 12 plus 8. That means 6s minus 4. Okay. And from denominator, you are getting s square minus 4s plus 4 plus 16. So ultimately, you are getting s square minus 4s plus 20. Clear? So you can write in this form. So obviously, you can see here in numerator, the term is s minus 2. And in denominator, the term is s minus 2. That means you can see, or you can say that the term s or the variable s is replaced by s minus 2. Yes or no? So obviously this term, this is our f of s minus a. Yes, that means f of Laplace inverse f of s minus 2. So according to the formula of fast shifting property, the answer will be e to the power 2t f of t. Okay, but we don't know the value of f of t. So in place of f of t, you can write e to the power 2t Laplace inverse f of s. Yes or no? Laplace inverse f of s. This is our f of t, na? So Laplace inverse f of s, that means in place of s minus 2, again you have to write s. Okay, so this is equals to e to the power 2t Laplace inverse, in place of s minus 2, we have to write s. So that will be 6s plus 8 divided by s square plus 16. Clear? So this is equals to e to the power 2t. Laplace and Laplace inverse always satisfy linear property. So you can write 6s divided by s square plus 16 plus 8 into Laplace inverse 1 by s square plus 16. Clear? So this is equals to e to the power 2t. Acha, 6 is common. So you are getting Laplace inverse s by s square plus 16 plus 8 into. Here the term is 1 by s square plus 16. And we know that Laplace inverse, Laplace of sin at or cos at, the denominator will be s square plus s square. And in case of sin at, the numerator will be a. And in case of cos at, the numerator will be s. But here you have constant number 1. So obviously s is not possible. Okay, but formula is you need a by s square plus s square, but you have 1, na? And what is the value of a? A is equals to 4. This is 4 square. So to get 4 on numerator, I am dividing 8 by 4. Okay, so I am dividing by 4, and here I am multiplying 4. S square plus 16. Clear? So the final answer is e to the power 2t into, this is 6 cos of 40 plus 2 into sine of 40. Okay, so if you take common 2, so that will be 2 e to the power 2t 3 cos of 40 plus sine 40. This is the final answer. Okay, clear? So very simple. Just you have to see that if the given function f of t, this is multiplied by e to the power at, you can use fast shifting property of Laplace transform. Similarly, if s is replaced by s minus a, then you can use fast shifting property of inverse Laplace transform. Okay. Now come to the next topic, which is second shifting property. Second shifting property. Okay. In second shifting property, you will have two functions. Okay. So first, if Laplace of f of t, this is equals to f of s. Okay. This is our given function. Laplace of f of t equals to f of s. And you also will be given another function gt. Okay. Gt is equals to, and this function gt will be represented with the help of the given function f of t. Okay, so gt is equals to f of t minus a when t is greater than a, and 0 when t is less than a. Clear? So the given function gt, this is represented with the help of the given function f of t. How? The gt is equals to f of t minus a when the value of t is greater than a, and if the value of t is less than a, this is equals to 0. Okay. Now, so what will be the Laplace of gt? So then, and this is your second shifting property. Then Laplace of gt, this is equals to, just very simple, you have to multiply e to the power minus as with f of s. And what is f of s? This Laplace of f of t. Clear? So simple, you have to multiply e to the power minus as with f of s. Okay, this is second shifting property for Laplace transform. Clear? Similarly, what will be the second shifting property for inverse Laplace transform? Okay, this is for Laplace transform. Now let's write the formula for inverse Laplace transform. So for inverse Laplace transform, the formula will be Laplace inverse e to the power minus as f of s. So obviously this is equals to gt. Yes or no? From this equation, this is equals to gt, and you know what is gt? Gt is equals to f of t minus a when t is greater than a, and 0 when t is less than a. So ultimately you are getting Laplace inverse e to the power minus as f of s. This is equals to f of t minus a when t is greater than a, and 0 when t is less than a. This is the formula of second shifting property for inverse Laplace transform. Okay, let's solve a problem for second shifting property. Find Laplace of f of t. Find Laplace of f of t where f of t is defined by f of t is equals to cos of t minus 2 pi by 3. Okay, when t is greater than 2 pi by 3, and 0 when t is less than 2 pi by 3. Okay, so you have to find out the Laplace of this function cos t minus 2 pi by 3 when t is greater than 2 pi by 3, and 0 when t is less than 2 pi by 3. Actually, if you compare this problem with the given formula, this formula, then obviously you can see that this function cos t minus 2 pi by 3 0, this is nothing but this is our gt function. Yes or no? Gt is equals to f of t minus a when t is greater than a and 0 when t is less than a. Yes or no? So which is our gt function? Here it is represented by capital F of t. Clear? So tell me, what is the original function? Original function means, according to the definition, original function means f of t. So what is the original function? This one, na? F of t minus a. That means ft is our original function. So obviously here you are given cos t minus 2 pi by 3. That means cos t. Cos t is our original function. Yes. So you have to find out Laplace of cos t. And you know what is Laplace of cos t? Sorry, s by s square plus 1. And this is nothing but this is our f of s. Yes. Now you have to find out. Okay, let take it as g of s, because according to the given question f of t equals to this. So I am taking this is g of s. So what will be Laplace of f of t? F of t means this function. Okay, according to the given property, our f of t is gt. Okay, so what is Laplace of f of t? Just simple, you have to multiply e to the power minus as with f of s. Okay, so e to the power minus as into, here f of s means gs. Okay, so you are getting the final answer. So this is equals to e to the power, what is the value of a? 2 pi by 3. So e to the power minus 2 pi s by 3 into, what is gs? Gs means s by s square plus 1. Okay, this is the final answer. Okay, very simple. Let's solve another problem. Question: find Laplace inverse of 8 e to the power minus 3s divided by s square plus 4. Okay, and this question is very, very important. This is the question from previous year paper. Solution. Here you can see that e to the power minus 3s, this is multiplied by 8 by s square plus 4. And you can take a look on the formula of Laplace inverse. When e to the power minus as is multiplied by f of s, that will be the result, f of t minus a and 0. Okay, so obviously you can see that here f of s, this is equals to 8 by s square plus 4. Yes, so Laplace inverse f of s, this is equals to, okay, so this is 4 na, 4 means 2 square, so you can write 8 as 4 into 2. Okay, so 4 into Laplace inverse of 2 by s square plus 4. Okay, so this is equals to 4, so this will be sine 2t. So 4 sine 2t, this is your f of t. Okay, now according to second shifting property, Laplace inverse 8 e to the power minus 3s, 8 e to the power minus 3s divided by s square plus 4, that will be equals to, formula is f of t minus a when t is greater than a and 0 when t is less than a. So you are getting 4 sine 2, t will be replaced by t minus a. So 4 sine 2 t minus, what is the value of a? A is equals to 3, so t minus 3. Okay, and when this is t is greater than 3 and 0 when t is less than 3. Okay, this is the answer. if you want to simplify this, so 4 sine 2t minus 6 when t is greater than 3 and 0 when t is less than 3. Okay, I hope first shifting property and second shifting property is now clear. If you have any doubts, ask me on the comment section and try to solve your textbook problems or question bank problems. Okay, thank you so much.